So in this, have you guys tried all the problems?
Yes.
Yes, भैया.
Okay, good. Okay. So if you have any confusion, just do let me know in between. Okay. So in the first problem, it says that in STR, time ordering of event is relative, but some events are connected by cause-effect relationship. So when Messi scores a goal, there is no frame in which the ball crosses the goal line before Messi kicked it. Okay. So it's like cause and effect. If you do not do this, it cannot happen in the future, something like that. So suppose two events A and B. A occurs at xa comma ta, and it is given to us that these are 0 comma 0, and later when B is occurring here somewhere at xb comma tb, and also it is given to us that tb is happening in future. Okay, it's tb is greater than ta, which is actually 0, so tb is greater than 0. This is given to us. Now we have been asked what is the condition on xb such that in all inertial frames event b occurs after event a. Suppose we are in some s prime frame which is moving at speed v, and in this frame also we want the same thing to happen, like event b should happen in future. That means tb prime must be greater than ta, right? This will be the condition. What is the condition on xb such that event b occurs after event a? From this line we can say that tb prime must be greater than ta prime. Now we want to find the condition on xb. We will just write the Lorentz transformation for tb and ta. So it will be gamma times of tb minus ta. Do you guys remember the Lorentz transformation for t? T minus
Yes, भैया.
vx by c square, right? So it will be xb minus x. This will be the Lorentz transformation, and we want it to be greater than equal to 0. So from here we can say that tb minus ta should be greater than v by c squared xb minus xa. Let us put this ta value and xb value to be 0. So our tb should be greater than v by c square of xb. Okay. So this is the condition. If we This is the condition on xb for which the event of b will be happening after event a. Now let us see the extreme conditions. So what will be the maximum value of the frame you can have? Maximum speed of the frame you can have is c, right?
Yes.
Maximum it can go with c. So that's why at extreme condition the te will be greater than xb by c square. C. This is the at extreme condition. Or what we can have is, if our v is pointing along this direction, minus x direction, that means we can have minus c also. For that, we will have our tb should be less than equal to minus of xb by c, right? This will happen for what? When our xb is less than 0. And this will happen when our xb is greater than 0. Like if our b point is somewhere here, along when xb is greater than 0, then the frame should be moving along this direction. And if our xb is in negative direction, then our frame should be moving along this direction. So now if we plot them, if we plot the extreme conditions of TB, let us plot t versus x, then our t is equal to v by c square xb. We want to see this at v equal to c. So this line will be a straight line passing through origin and with slope 1 by c for x greater than xb. So this will be the line which will correspond to T is equal to 1 by C xp. Now suppose you are here, okay? What will be the slope here? Slope will be greater than 1 by C, right?
Yes, Vijay.
And here the slope will be less than 1 by C. Now, if the slope, so basically this slope was coming from like this, C by C square. So we will be getting that C, this will be C by C square. And if you compare this with this slope V by C square, that means your in this region, your speed is actually greater than C. Are you guys with me? And
Sir,
in
yes,
this
Vijay.
region, your speed will be less than C. So which is possible? Which one is possible and which one is not?
Lower region.
This region is not possible, right? That
Yes,
means this region will definitely happen in future. Like if you move, you cannot achieve this region because you cannot move beyond light speed. So that's why this region will happen in absolute future. Similarly, if you draw for x is equal to for x less than 0 for negative xb, the line will be with negative slope and this region will correspond to the absolute future. That means this region will correspond to absolute future. That is what we were asked actually. So the region on the graph whose points correspond to the events that occur in absolute future. So this will be the region. And event V was occurring here, it was already given. Okay.
Yes, PM.
Now question number 2. Suppose S prime frame is moving with respect to S frame with speed this. So we are again given two frames. S and S prime, and S prime is moving with V is equal to 0.6 c. In S prime frame, a particle has speed u prime. So in S prime frame, particle is moving with u prime, and this is also given to us root 2 by 5 c. Now you calculate the gamma corresponding to this. Gamma of corresponding to this will be 1 by root over of
Yeah,
1 minus v
is
square.
and minus.
45 degree. Speed of particle is at 45 degree with x.
Okay, yeah. Speed of particle is at 45 degree. Thank you. So it's going like this with this speed. And gamma for the frame will be root over 1 by 1 minus v square by c square. So it will come out to be equal to 5 by 4. Now, component of u prime, this is 45. Along x-axis will be
Point two
u
C.
prime x will be root 2 by 5 c cos 45, which will be c by 5, and component of y u prime along y will be again c by 5. So we know what is the velocity component of particle in S prime frame. Now we want to know what is the angle of the velocity vector n x-axis as seen by S frame. So suppose we somehow get to know ux and uy in S frame, then by writing tan theta is equal to ui by ux, we can find it. So let us find what is ux and uy. To find ux, you know that the particle is moving along this direction, along x direction with this speed. And you also know that the frame is also moving along this direction with v speed. That means from s we have to use velocity addition formula to get ux. What is the velocity addition formula? Is ux prime plus v divided by 1 plus ux prime v by c square. Okay? So ux will be this, and uy is similar, uy prime, but there is no frame speed along y, and it looks similar to this, okay, by c square, but there is also a gamma here. This gamma, this derivation you will be get, you might have got by using Lorentz transformation. So this velocity addition formulas actually you have to remember. Now you put ux will be coming to be what ux prime was our c by 5, v is our c.6c, that means 3 by 5, 3 by 5, 1 plus you be very careful that this is ux prime, okay, not u, not u prime. 1 plus c by 5 into 3c by 5 by c square, and if you do it, it will come out to be equal to, okay, it will come something same way. Uy you will get, uy will be equal to c by 5 divided by gamma we have already found 5 by 4, and 1 plus c by 5 into 3c by 5 by c square. Now if we take tan theta, then this term and this term will get cancelled. So it will be c by 5 divided by 5 by 4 into 4c by 5, which will be 1 by 5. That means that angle we will get is tan inverse 1 by 5. Everybody understood this problem? What we do it is, we first find the component of velocity in s prime frame along x and y direction. Then we use velocity addition formula to find the component of speed, component of velocity in s frame. Uh, I could not hear you.
Yes, sir. Yes, Bhaiya.
Okay. Then just using the tan theta is equal to ui by ux, we can find the angle. That's it. Next is the third problem. So one of the most prominent lines in the spectrum of hydrogen is H alpha line, and it's a bright line, bright red line with wavelength this. So this is given to us. 1 second. Yeah. So this wavelength is given to us, and what is the expected wavelength H of H alpha line from a star receding away from with a speed this much? So there is a star which is, suppose we are here, observer is here, and with this star is moving away from us at a speed is equal to 3000 kilometer per second. Once we get a velocity, we will try to convert it in terms of c. So 3000 per kilometer means 3 into 10 to the power 3 into 10 to the power 3 meter per second. 3 into 10 to the power 6. We want to convert it to c. So let us divide it by 3 into 10 to the power 8 and multiply with c. So it will be c by 100. So the star is moving away from us with speed c by 100. Now, once it moves away from us, the frequency is Doppler shifted. So frequency observed will be equal to mu is equal to mu 0. If it is moving away, frequencies will decrease. So C minus V2. So इसलिए ऊपर the top part it is minus. And similarly, this part will also give us decrease 1 by C plus V. So I remember it like this. So when it is away, it's like this. Now you know wavelength and frequency are related as mu is equal to C by lambda. You know this, right? And this
Yes,
one,
bhai.
this one you have to remember. This is called Doppler effect, Doppler shift. Now you convert it to wavelength. So lambda d will be equal to lambda, lambda 0 C plus V divided by C minus V. Now you know what is the speed at which it is moving. So you just put it, it will be 656.1 nanometer. You see, it's in nanometer, right? What is the spectrum for visible light? 400 to 700 nanometer. And it is at the edge of this visible spectrum. C minus B, C minus C by 100 divided by C plus C by 100. Oh, sorry, C plus C by 100 by C minus C by 100. It will be 656.1 nanometer times. This will be 1 plus 1 by 100. That is, okay, it will be 101 by 99. So you simplify this, it will be 1 plus 2 by 99 to the power half. Although we cannot directly write 1 plus nx because it's approximately around 1%. So we will be writing 1 plus nx. So it will be 1 by 99. This will be 1.01. So 656.1 nanometer times 1.01. So the wavelength as observed by us will be equal to 662.7 nanometer. And this is how actually we try to calculate the speed of stars. Okay, and because all the stars has hydrogen, so it used to emit this H alpha line, and we know what is the actual actual wavelength of H alpha line, and when it moves towards us or away from us, we we will be knowing, we can detect the wavelength here. Then finally by calculating using this approach, we can find the speed of the star. This we actually do in real life also.
Bhaiya, uh,
Yes.
I did from a different approach, but my answer was wrong. So can you tell my mistake in that?
Uh, okay. So
I
how did you try?
I considered two frame on planet Earth, S
Okay.
and S dash. S dash was moving with velocity 3 into 10 to the power 6 meter per second.
Mhm.
At at t equals to d is 0, t dash was equal to 0, and this was the moment at which the starting point of the light ray touched the Earth's surface.
Uh, it means I have to think on this. Can you send this solution to me so that I can check and I will give a comment on that.
On the Teams group only, or
You can
do you
personally share also, or you can put it in this group also.
okay?
Next, the H alpha line measured on Earth from now. This is different question. H alpha line measured on Earth from opposite end of Sun's equator differs in wavelength by this much. Now, and assuming that the effect is caused by rotation of the Sun. So we are assuming that Sun is not moving away or towards us. It is stationary, but it is rotating. So it is rotating on its axis. Suppose this is the axis out of the plane along with omega. So this shift is basically caused because of this rotation. It is given, and diameter of the sun is also given. and we want to know what is the time period of rotation. So when the sun will rotate, it will emit the even it is stationary, it will emit photon, that we know. Suppose we are here, so we will see that from this edge one photon will be coming. From this edge also we will see one photon will be coming. But the photon, suppose this is A, this is B. The photon coming from this will be coming out from a frame which is having speed along this direction of r omega. Everyone agrees because this is rotating.
Yes, भैया.
Same way, photon coming from this will be coming from a frame which is actually moving along this direction at speed Vb is equal to r omega. So this source is moving towards us, but this source is moving away from us. That means we will definitely detect a change in a wavelength, right? This wave, suppose this will be lambda A and this will be lambda B, then both of them will be different. So let us find a difference in wavelength. So which wavelength will be bigger, by the way?
Going away side.
Going away one. So lambda B will be bigger. So let us find what is the difference in wavelength. Lambda B minus lambda A. It will be lambda 0. Same, this was going away formula. C plus V by C minus V minus. Now if it comes towards us, then we will write C. In place of V, we will write minus V. This is our delta lambda observed from Earth. Now we have to simplify this. Let us simplify first this one, C plus V by C minus V. So it will be 1 plus V by C into 1 minus V by C to the power minus 1. Everyone agrees still here?
भैया.
1 minus r to the power minus 1. We can write as infinite series, right? Infinite GP series. 1 plus V by C whole square dot 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 up to infinity. Now suppose V is very less than C. This one we do not know yet, but suppose even if we assume like this and we reach towards the speed around C, then our assumption will be wrong. But if we assume like this and we reach to a step that V is really very less than C, then our assumption will be correct. So in this case, we can ignore these terms. So our solution will be, this thing can be written as 1 by V plus C. 2 times it will come with a square root, so it will become 1 plus V by C approximately. So we got that this is 1 plus V by C and this is 1 minus V by C. So you simplify it, we will get that 1 will get cancelled, 2 lambda 0 V by C. Now we put the values. We want to calculate V. So V is equal to C into delta lambda is given to us 9 into 10 to the power minus 3 nanometer. It was given 9 picometer. So I am writing it is equal to 9 into 10 to the power minus 3 nanometer. 2 into 656.1 nanometer. So this will be equal to C into 6.86 into 10 to the power minus 6. It will be coming like this. Now you see our V is really very less than C. That means our assumption was very correct. So our V will be equal to 2.06 into 10 to the power 3 meter per second. Now we have to find the time period. Time period will be equal to 2 pi by omega, and we know our omega was equal to V by R. R means d by 2. So if you simplify this, we got that our time period of rotation in terms of diameter and the speed will be equal to this. And if you put the values, it will come out to be, okay, let me. So it will be 3.14. Diameter is given to us 1.4 into 10 to the power 8, 10 to the power 9 meter. Speed is 2.06 into 10 to the power 3 meter per second. This will be very big number, okay, in seconds. So let us convert it into days. So if we convert it, it will be like this: 8.64 into 10 to the power 4 second, and this will giving us approximately 25 days. So from these calculations, from this information, we will be able to calculate the time, calculate the time period of rotation. It's approximately 25 days. So this is a very important tool we use in astronomy. What is the speed of star? What is the rotation of the star? How it is what is this composed of? All those stuff we can read, and you will be learning all those stuff in higher classes.
So yeah,
Any
Hubble's law
confusion?
must have been discovered like this only, right?
Yes. Now question number 4. In laboratory frame, a particle of mass m0 and speed v. So rest mass is given to us and speed is also given to us, moving towards a particle of mass m0 which is at rest. Now this is in laboratory frame. So this is the S frame. What is the speed of inertial frame in which the total momentum of the system is 0? So we there is another frame S prime which is moving with speed some v prime, suppose. So in this frame we want that the total momentum should be equal to 0. So suppose in S prime frame the particle 1 is having v1 prime speed and particle 2 is having v2 prime speed. So what will be v1 prime then? Anyone?
Yeah,
v1 prime is basically
V
yeah,
by
V minus, I mean, I've written U as U minus V upon 1 minus UV by V.
yes, that velocity addition formula we have to
Yes,
use.
yes.
So velocity speed of 1 with respect to S prime we want to find. So how I used to write was, if we do in Newtonian, so we will be writing speed of 1 in S minus speed of S, this like this we will be writing, right, in Newtonian, speed of 1 with respect to S plus speed of S with respect to S prime. But in relativity we have to put one more factor, 1 plus this value into this value by c square.
Yeah, minus would come, right?
Yeah, I will tell you. But we know our v s prime s is equal to v. Speed of s prime with respect to s is v. So speed of s with respect to s prime will be equal to minus v. So finally, our v1 prime will be in v1 is speed of 1 with respect to s is v. Speed of s with respect to s prime is this one. I was assuming v prime. Okay, v prime minus v prime, then 1 plus v into minus v prime by c square. This will be the speed v minus v prime by 1 minus v prime by c square. Okay, this will be the speed of 1 in S prime frame. Same way, what will be the speed of 2 in S prime frame?
V prime minus V
Minus
prime.
prime.
Minus v prime. Okay, now let us find the momentums. In the particular, what is the speed? Total. Okay, total momentum we want to find. So, what will be the momentum of one in S prime frame? So, momentum formula in relativity is gamma m0 v. Okay, this is the formula. So momentum of 1 in S prime frame will be equal to gamma m0 v1 prime. Momentum of 2 in S prime frame will be gamma m0 into v2 prime. Now v1 then our p1 prime plus p2 prime is equal to 0. Okay, let us suppose also that p1 prime is along this, p2 prime is along this. So it will come out to be minus here. So finally our expression will look like this. Now tell me, if these things are equal, if the momentum, if total momentum is 0 and they are identical particle, should the speed be same?
Mm, Yes.
Yes, yes.
Yes, because they are identical particle, that means their speed should be equal in opposite. That means their gamma should also be equal, right? Because their speeds are equal, that's why their gammas are equal. So we can write v1 prime is equal to v2 prime. Now you substitute from the velocity addition formula these two, and we will get. Now if you put it, finally it will look like v minus v prime is equal to v prime minus v prime by c square. If you solve this equation, your, okay, let me check the solution. It will come a quadratic equation, okay? V prime square, okay, this one. So your solution will look like v prime will be equal, speed of the frame will be c square by v 1 plus minus 1 minus v square by c square to the power half. This will be your speed of the frame. Now tell me, can we write, can both the plus and minus solutions will be acceptable or not?
No.
No, bhaiya. For plus, it will be greater than speed of
Yes, because if we use plus, this speed will look, v prime will be greater than c, so that's why this speed is not acceptable. So the final solution will be c square by v, only the negative part, 1 minus v square by c square to the power half. Okay. Now if you check for the classical case, non-relativistic case, v prime is very less than c, sorry, speed of the particle is very less than c, then your v prime will come out to be equal to this one, c square by v, 1 minus 1 minus v square by 2c square, approximately, right? 1 minus nx we can write. It will come out to be c square by v, 1 will get cancelled, v square by 2c square means v by 2. So the speed of particle, speed of the frame should be v by 2. This is acceptable, right? If a particle is moving with speed v to rest and non-relativistic limit, then if our frame will move at v by 2, then in this frame the speed of this will become v by 2, and in this frame also speed of this particle will become v by 2. Then the total momentum will become 0 in non-relativistic case. That means our solution is correct. Are you guys convinced? Are you guys with me?
yes,
Yes.
bhaiya.
Okay, good. So the next
Yes.
question. Next question is, a photon of energy this is collides with a particle of mass m0 at rest. So a photon is coming with this energy and it collides with a particle which was at rest. Then finally what happens, if scatters the photon of an angle theta. So the photon finally moves along this direction at an angle theta, and because it makes theta, the particle will also move. It cannot move in this direction. Why? momentum will not be conserved, right, in y direction. So the particle should move along this direction so that the momentum will remain conserved. This. Suppose we assume that final momentum and final energy of the particle is this E comma P, and final energy of the photon is epsilon. This is what we assume. Now let us write the initial energy. What is the initial energy of the system?
Epsilon naught plus mc square.
Yes,
Naught c square.
m naught c square. The initial energy is photon energy plus m naught c square. What is the initial momentum along x direction?
Epsilon naught by
Epsilon
c.
Okay, oh, I have,
by c.
so, wait, I solve it actually along opposite direction. So let me solve the same way so that I can directly write the answer. I have put the particle along this direction and photon along this direction. So photon is moving energy E comma P. This angle is phi and this angle is theta. Yeah. Px will be, what is the momentum,
Epsilon naught.
initial momentum?
Epsilon naught
Epsilon
by c.
0 by c. Because it is photon, P is equal to E. E is equal to EC relation will hold for photon. From here we are writing P. So, what is Py?
0.
0. Pz is also 0. We will not write. Now what is the energy after collision?
E.
So, okay, this is epsilon I am writing. So epsilon plus
plus
E,
e.
right?
Yes.
And what is the Px?
Uh, epsilon by c plus epsilon by c cos theta plus
Yes.
P cos phi.
Yes.
plus p cos phi. Yeah.
And what will be Py?
Epsilon by c sin theta plus p by
Minus, right?
minus actually, yeah, minus.
Minus P sin phi. So this, now you see what are the variable we have introduced? 1, 2, 3, 4. But we have 3 equations. Uh, we already know that we know E and P of this particle will be related as E square is equal to P square C square plus M naught square C power 4. So the fourth equation will be coming from this. So we have 4 equations, 4 variables, we can solve it, but it's not that easy to solve. So you also try. So first from here we write what will be E square. Okay, E square will be epsilon 0 plus m0 c square minus epsilon whole square. If you simplify it, it will become epsilon 0 square plus epsilon square plus m0 square c to the power 4 plus 2 epsilon 0 m0 c square minus 2 epsilon 0 epsilon minus 2 m naught c square epsilon. From this line is clear, right? I am just keeping the e in one side and squaring it. Are you guys with me?
Yes, yes, yes.
From these two, I want to write p cos theta in one side and p sin phi in one side, then squaring it. So let me find e square c square. So this part will go this way. So it will be epsilon 0 minus epsilon cos phi whole square plus epsilon by epsilon sin phi whole square. If you simplify it, it will give epsilon 0 square plus epsilon square minus 2 epsilon 0 epsilon cos phi. Everyone agrees still here?
Yes, yes.
Okay,
Yes,
good.
Bhaiya.
So now just subtract these two equations. If we subtract e square minus p square c square, you will get m naught square c power 4. From here, this term and this term will get cancelled. This term and this term will get cancelled. Then anything will cancel? No. So finally the expression will look like m naught square c power 4 minus 2 epsilon 0 epsilon minus 2 epsilon m naught c square plus 2 epsilon 0 m0 c square plus 2 epsilon epsilon 0 cos theta. This will be theta because this was giving there. Now you simplify it and you find what is epsilon 0 by epsilon. From this equation you will get epsilon 0 by m naught c square 1 minus cos theta plus 1. Why we are doing this? Because we finally want to know what is the angle, right? What is this scattering angle? Now if you use this equation and find cot phi, then we will get epsilon 0 minus epsilon cos theta divided by epsilon sin theta. From here you will be requiring epsilon 0 by epsilon cosec theta minus cot theta. You simplify this. Now epsilon 0 by epsilon you already know. This is this much. So if you simplify it, then let me check the final answer. You substitute it and finally you will get 1 plus epsilon 0 by m naught c square tan theta by 2. Okay. So this will be the angle at which this particle will scatter. This is actually called Compton effect. And these calculations you will find that this is very trivial. You can solve it, but if you try to solve now, it will take very long time if you do not try more. So you try once these calculations. Okay. This is so what we did in this question is first write the energy momentum relations. Then we also use the energy momentum relation E square is equal to P square C square plus M naught square C power 4 formula. So if you utilize this conservation of energy momentum and this relation, then you will achieve the answer. Okay, any doubt?
No idea.
Okay. Next, the final problem. So the negative pion has mass this much. So pion's mass is given to us. Suppose this mass is m phi. Then it decays into mu1 and a neutrino. So it after this it will decay into a mu1 and a neutrino. Mu1 has mass this, so mu1's rest mass is also given to us m0, and rest mass of neutrino is given to us that it is massless, approximately 0. And this energy mass convergence units are also given to us. So let us also write this. It's given that 1 AMU is equal to 1 kg is this much, 6 into 10 to the power 26 AMU. Now see, AMU is the unit of mass. Now if you want to convert a mass into energy, how to convert? We know E is equal to mc square, right? That means you have to multiply this AMU with c square, then only you will get an energy unit. Okay. So 1 AMU into c square is actually 931 MeV. This is given. So wherever we will have to convert 1 AMU to energy, we will be writing 931 MeV per c square. Okay, this we will be doing in further calculations. Next, we will ask what are the energies of the mu1 and neutrino in pion's rest frame. So pion was actually at, suppose pion is at rest. When it will disintegrate, it will have some energy and momentum. Suppose energy of this is E mu and momentum is P mu. And then what? And then same way, energy of neutrino is E nu and momentum is P nu. So initial energy will be E pi. Final energies will be E mu plus E nu. This line is fine, and a conservation of energy. Then momentum
Yes, yes.
P pi will be equal to P nu minus P mu. This is given to us as 0 in pion's rest frame. So it will be P mu will be equal to P nu. From here we got. Next, E pi. What is the energy of this pion?
M naught c square.
M naught c square, because it was not moving. M naught 0 pi c square. What will be the energy of muon?
Mm,
We don't know.
Kinetic energy plus
Muon
M
we
naught.
know.
Kinetic energy plus M naught mu
Yeah.
square c square.
Let us keep this like this only. We can find this E nu because it is rest.
CC.
It's
P mu c.
E square is equal to P square C square plus M naught square C power 4. So because mu1 is having 0 rest mass, so E is equal to PC we can write. Anyway. So we want to finally write what will be E mu square minus P mu square C square from this formula. It should give us M0, M pi 0, M square C power 4, right? Now you substitute E mu is equal to M0 pi C square minus E nu whole square minus P nu square C square. So if you substitute this, finally you will get that E nu is equal to M. I will not writing this 0 again. M pi square plus M mu square minus M mu square whole into C square by 2. You just have to do this calculation, then you will reach this step. M pi. This will be the energy of neutrino, and for energy of muon, it will be M pi square. But these things will be reversed. In place of this, it will come this M mu1 square minus M neutrino square divided by 2M square into C square. So here is 2. This is same, okay? It will be pi only. These two things you will get. Now you know that the neutrino mass is 0, so this will be 0. This will be 0. Now you substitute. Before substituting, we want to write what is M pi mass of pions in C square unit. It is equal to 2.49 into 10 to the power minus 28 kg. We want to convert it to AMU. 6 into 10 to the power 10 to the power 26 AMU, and 1 AMU is 931 MeV. M pi C square is this much, which is, if you find, it will come out to be equal to 139.16 MeV. Okay. Similarly, if you do for muons, M mu C square will come out to be equal to 105.57 MeV. Now you just substitute. This one you can do is by multiplying C square above and below. You know this value, and you can substitute here. Are you guys with me?
Yes, भैया.
Okay. So you just substitute the first you have to know how to do this. Okay, this we do first. Write the kg in terms of AMU, then the AMU in terms of MU. Then it will come out to be equal to this much. Energy of the neutrino will come out to be this much, and energy of the muon will come out to be equal to 109.62 MeV. This is done. Next, we will ask what is the momentum of
भैया,
neutrino. हाँ
I
बोलो.
mean, थोड़ा सा ही like uh, I am getting 29.5 MeV and 109.5 MeV. That's what approximation is right now. I mean,
Yeah, it's fine. It's fine.
okay.
You must have neglected some numbers, maybe.
Yeah, I mean, I did थोड़ा सा different.
Yeah.
Bhaiya, if we use in this energy mass relationship, will that give directly kinetic energies of sum of kinetic energy of muon and neutrino?
Uh, can you repeat again?
If we use energy mass relationship like
Hmm.
we did in atomic physics in
Mhm.
12th, that the remaining mass of the neutrino of the first element directly converts into energy. So will it give only a sum of kinetic energies or something else?
Kinetic only. I did by that method only.
No, your total energy will be equal to kinetic energy plus rest mass energy.
Yes.
If you have done it like this, then it's fine. Like you have to write the rest mass energy also, okay? Because neutrino case, you can write energy is basically the kinetic energy, but for the muon, you cannot simply write energy is only the kinetic energy. It is also having rest mass energy.
Yeah, भैया, that थोड़ा सा doubt I have there. Like I have taken like the reduction in total mass of both side of the decay,
Mhm.
that I have taken to be the sum of kinetic energies of the particles, neutrino and muon, but I have done using this equation only, that
Okay,
E is equal to Ke plus rest mass
then
energy.
it's fine. Yes.
Yeah, that is how I'm getting those
Mm.
nine.
Uh, Bhaiya, but how can we say that it is a rest mass of that neutrino? My doubt is that since it is given in the condition when neutrino was ejected, so how can
Mhm.
we and it is not written it is rest mass. So how can we say that it is a rest mass or mass when it was moving?
Actually, all these masses are rest mass. It has not been mentioned, but these masses are rest mass. Okay. Now, moving to the B part. What is the momentum of neutrino? What will be the momentum of neutrino? How to do it? Using this relation, right? E nu is equal to, E nu square is equal to P nu square C square plus M naught square C power 4. Because this is 0, we will be getting P nu is equal to E nu by C. If you convert it, it will come out to be equal to 29.54. This 29.54 MeV by C. This will be the neutrino momentum. Now we want to find the speed of muon.
Yeah, a small doubt here also.
Yes.
I mean, it is not very required to give in SI units, right? We can leave the
No.
momentum in MeV per C.
Yes.
Okay.
Now speed of muon. Speed of muon, because you know P mu is equal to gamma m0 mu times of V mu gamma mv. You don't forget this gamma, okay? This is the momentum of muon. And you also know what is the momentum of muon, gamma m0 mu c square. Now you divide from here uh, p mu by e mu. It will come out to be equal to v by c. V by c square, right? So from here you can find v is equal to p mu c square by e mu. P mu we have already found. it will be equal to the neutrino momentum, which will be 29.54 MeV by C. This is multiplied with C square. And what is E mu? E mu we have found at 109.62 MeV. So velocity will come out to be equal to 0.27 C. Yeah, this much speed it will be having. This is the speed of the muon. Similarly, if you go to find speed of neutrino, P neutrino C square by E neutrino, how much it will become? Are you guys with me?
Yes, it will come to be C only.
Yes, it will come to be equal to C. So don't forget this gamma. This gamma will carry very significant meaning. If you miss this gamma, then if you write P nu is equal to M0 nu time, okay, if you miss this gamma, then what will happen? P nu is equal to M0 nu into V nu, V neutrino. Because your neutrino is having zero mass, then momentum you have already found some zero. That means this will diverge, right? So that gamma was actually taking care of that. So that's why you don't miss this stuff. Okay.
Yes, Bhaiya.
So anyone have any other doubt? So one person asked me something. Can you just send the solution to me and I will check and discuss with you?
1 minute, Bhaiya.
Okay.